Imagine standing beneath a vast, star-studded sky. The Milky Way stretches across the heavens, a river of light composed of billions of stars. We find ourselves on a small planet, orbiting an average star, in just one galaxy among countless others. Our cosmic address is humbling in its scope, reminding us of the vastness that surrounds us. Each atom in our bodies was once forged in the heart of a star, the remnants of cosmic events that played out over billions of years. We are quite literally stardust. This profound realization sets the stage for our exploration of everything that has ever been, from the universe's fiery birth to this very moment. It's about our place in the cosmos and the incredible journey that brought us here. Join us as we embark on an epic adventure through time, tracing the grand narrative of the universe from its explosive beginning to the present day. The universe is brimming with stories, waiting to be told. So, let us begin our journey at the beginning, at the moment when the universe as we know it burst forth into existence, the Big Bang. Picture, if you can, a universe condensed into a point smaller than an atom. In this infinitely dense and hot speck, all of space, time, matter, and energy were concentrated. Then, 13.8 billion years ago, something extraordinary happened. This point began to expand, not just outward into pre-existing space, but space itself began to stretch and inflate. From this unimaginably small and hot state, the universe began to cool, and with that cooling came the first whispers of structure. Energy began to condense into matter. Subatomic particles flickered into existence, their interactions governed by the fundamental forces of nature. As the universe continued to expand and cool, these fundamental particles began to combine, forming the first protons and neutrons. Gravity, the architect of the cosmos, began to exert its influence, drawing matter together, sculpting the universe into the magnificent structures we observe today. As the universe continued to expand and cool, a pivotal moment occurred around 380,000 years after the Big Bang. The universe had cooled enough for electrons to be captured by protons and neutrons, forming the first atoms, primarily hydrogen and helium. This event, known as recombination, marked a significant transition in the universe's history. With the formation of neutral atoms, the universe became transparent, allowing light to travel freely for the first time. This first light, a faint afterglow of the Big Bang, still permeates the universe today. Known as the cosmic microwave background radiation, it provides us with a snapshot of the universe as it was just 380,000 years after the Big Bang. With the release of the cosmic background radiation, the universe entered a period known as the Dark Ages. The intense heat and light of the Big Bang had faded, leaving behind a vast expanse of darkness. But within this darkness, gravity was at work, pulling matter together, setting the stage for the formation of the first stars and galaxies. Over millions of years, gravity drew together massive clouds of hydrogen and helium gas. Eventually, the pressure and temperature at the cores of these nebulae reached a critical point, and nuclear fusion ignited. The first stars were born, blazing with a brilliance that pierced the darkness of the early universe. These elements, the building blocks of planets and life itself, would eventually be incorporated into new generations of stars and planetary systems, including our own. Imagine the early universe, not as a uniform sea of matter, but as a tapestry of subtle density variations. These tiny fluctuations, remnants of the Big Bang's fury, acted as seeds for gravity to work its magic. Over eons, gravity relentlessly drew in surrounding matter, amplifying these subtle differences. Vast clouds of hydrogen and helium gas, enriched with the remnants of exploded stars, began to coalesce under their own gravity. These massive structures, spanning hundreds of thousands of light years, became the birthplaces of galaxies. As galaxies formed, they were not randomly scattered, but instead were drawn together by gravity's invisible hand. This intricate web, with its filaments of galaxies and vast voids, is a testament to the power of gravity to shape the cosmos on unimaginable scales. Within the swirling clouds of gas and dust that populated young galaxies, a celestial ballet was underway. Dense pockets of gas, nudged by gravity or the shock waves of nearby supernovae, began to collapse under their own weight. As these pockets contracted, they spun faster and faster, like whirling ice skaters pulling in their arms. The increasing density and rotation generated intense heat and pressure at the core of these collapsing clouds. Temperatures soared to millions of degrees, hot enough to initiate the process of nuclear fusion. This sudden release of energy marked the birth of a star, a celestial furnace that would illuminate the surrounding darkness for millions or even billions of years. Stars, like cosmic lighthouses, became beacons in the vastness of space, their light and heat influencing the evolution of their surroundings. As stars ignited within their stellar nurseries, they were not alone. Surrounding each newborn star was a swirling disk of leftover gas and dust, remnants of the cloud from which the star had formed. This disk, known as a protoplanetary disk, would become the birthplace of planets. Within this swirling chaos, dust grains, tiny particles of rock and ice collided and stuck together. Over millions of years, these collisions built up larger and larger objects, from pebbles to boulders to planetesimals, the building blocks of planets. Closer to the star, where temperatures were hotter, only rocky material could withstand the intense heat. These rocky planetesimals coalesced to form the inner terrestrial planets, like our own Earth. In the vast expanse of the Milky Way galaxy, within an unremarkable arm, our own solar system was taking shape. Roughly 4.6 billion years ago, a swirling cloud of gas and dust collapsed under its own gravity, igniting the birth of our Sun. Around this nascent star, a protoplanetary disk formed, setting the stage for the formation of Earth and its celestial siblings. Within this disk, rocky planetesimals collided and coalesced, gradually building up the mass of our planet. One particularly violent collision, with a Mars-sized object, is thought to have blasted debris into orbit around the young Earth, eventually forming our moon. The early Earth was a hellish world, bombarded by asteroids and comets, its surface covered in molten rock. Over time, the bombardment subsided, and the Earth began to cool. Imagine the early Earth, a world vastly different from the one we know today. Volcanoes spewed molten rock and gases into a thick, noxious atmosphere. Lightning crackled across the sky, illuminating a landscape devoid of life. Yet, within this seemingly inhospitable environment, the stage was set for one of the most remarkable events in the history of the universe: the emergence of life. The young Earth was awash in a warm, shallow ocean, teeming with a rich chemical broth of organic molecules. From the simple ingredients of water, organic molecules, and a source of energy, life emerged, forever altering the trajectory of Earth's history. In the warm waters of the early Earth, the first life forms were simple, single-celled organisms, much like bacteria. These early microbes possessed the remarkable ability to replicate themselves, passing on their genetic information to their offspring. At the heart of this extraordinary process is DNA, the molecule of heredity. DNA, with its elegant double helix structure, contains the genetic instructions for building and maintaining an organism. These instructions are encoded in the sequence of 4 chemical bases: adenine, A, guanine, G, cytosine, C, and thymine, T. The emergence of DNA was a pivotal moment in the history of life on Earth. For billions of years, life on Earth was dominated by single-celled organisms. These microbes evolved and diversified, adapting to a wide range of environments, from the depths of the oceans to the soils beneath our feet. Then, About 2 billion years ago, something extraordinary happened. Single-celled organisms began to cooperate, forming colonies and eventually multicellular organisms. This transition from single cells to multicellular life was a major leap in complexity, opening up new possibilities for evolution. Over millions of years, multicellular life diversified, giving rise to a dazzling array of plants, animals, and fungi. The diversity and complexity of life on Earth was exploding, driven by the relentless forces of natural selection. Around 540 million years ago, life on Earth underwent a dramatic transformation. Over a relatively short period of time, geologically speaking, a burst of evolutionary innovation occurred, known as the Cambrian explosion. During this period, new body plans emerged at an unprecedented rate, giving rise to most of the major animal phyla we see today. Creatures with shells, skeletons, eyes, and limbs appeared in the fossil record, showcasing an astonishing diversity of forms and functions. The Cambrian explosion was a period of experimentation, a time when life explored a vast array of possibilities. The Cambrian explosion was a pivotal event in the history of life on Earth, marking a turning point from a world dominated by simple, soft-bodied organisms to one teeming with complex, diverse, and often bizarre creatures. The history of life on Earth is not a linear progression, but rather a story of triumph and tragedy, of diversification and extinction. While the Cambrian explosion showcased the incredible diversity that life can achieve, it has also been punctuated by periods of mass extinction, when a significant portion of Earth's species vanished in a relatively short period of time. These extinction events, often triggered by catastrophic events such as asteroid impacts, volcanic eruptions, or rapid climate change, have profoundly shaped the course of evolution. The most famous mass extinction, the Cretaceous-Paleogene extinction event, wiped out the dinosaurs 66 million years ago, paving the way for the rise of mammals. While mass extinctions are undoubtedly tragic events, they also create opportunities for new forms of life to emerge and diversify. In the aftermath of each extinction event, survivors adapt to the changed conditions, filling vacant ecological niches and evolving new adaptations. The history of life on Earth is a testament to the resilience of life, its ability to rebound from catastrophe and create new possibilities. From the ashes of extinction, new ecosystems arise, showcasing the endless creativity and adaptability of the natural world. As the dinosaurs relinquished their reign, a new group of animals began to flourish in the shadows. These were the mammals, small, furry creatures that had coexisted with dinosaurs for millions of years. With the dinosaurs gone, mammals inherited the Earth, diversifying into a dazzling array of forms, from tiny shrews to gigantic whales. Among these early mammals were the ancestors of primates, the order of animals that includes monkeys, apes, and humans. These early primates were small, tree-dwelling creatures, adapted to life in the forests that covered much of the Earth. They possessed grasping hands and feet, perfect for navigating the branches, and their forward-facing eyes provided them with excellent depth perception, essential for judging distances in the trees. Over millions of years, primates continued to evolve and diversify. Some, like monkeys, remained primarily arboreal, while others, like apes, ventured down from the trees, exploring new habitats and evolving new adaptations. These early apes were the ancestors of all living apes today, including gorillas, chimpanzees, bonobos, and humans. It is within the ape lineage, on a single branch of the vast tree of life, that we find the origins of our own species. Around 6 to 7 million years ago, in the heart of Africa, dense forests receded, giving way to open grasslands and savannas. This led to the emergence of the first hominids, the group that includes modern humans and all our extinct bipedal ancestors. The open terrain favored bipedalism, freeing hands for tasks like carrying food and using tools. Fossils show a mosaic of features, adapted to both climbing and walking. Natural selection favored those best adapted, leading to human-like characteristics. As hominins ventured further out onto the savanna, they faced new challenges that required ingenuity and intelligence to overcome. They developed increasingly sophisticated tools, starting with simple stone flakes for cutting and scraping, gradually progressing to more complex hand axes, choppers, and scrapers. These tools, crafted with increasing skill and precision, allowed our ancestors to access new food sources, such as meat from animal carcasses, and to defend themselves more effectively against predators. The control of fire was another pivotal moment in human evolution. Fire provided warmth in the cool night air, kept predators at bay, and allowed our ancestors to cook their food, making it easier to digest and unlocking nutrients that would otherwise be inaccessible. But perhaps the most significant development in human evolution was the expansion of the brain. With larger brains, hominins became capable of abstract thought, language, and complex social interactions. They developed the ability to plan ahead, to communicate their ideas, and to pass on their knowledge to future generations. These cognitive abilities, coupled with the use of tools and fire, set the stage for the emergence of our own species, Homo sapiens, approximately 300,000 years ago. Africa is the cradle of humankind, the place where our species first evolved. But our ancestors were not content to remain confined to their ancestral homeland. Driven by a combination of curiosity, the search for new resources, and perhaps a sense of adventure, they embarked on an extraordinary journey that would take them to every corner of the globe. The migration of humans out of Africa is a testament to our species' adaptability, resilience, and unquenchable thirst for exploration. The details of these migrations are still being pieced together by archaeologists and geneticists, but the broad outlines are becoming increasingly clear. The earliest evidence for humans outside of Africa comes from the Middle East, suggesting that our ancestors first left their homeland around 100,000 years ago. From there, they spread eastward, reaching Asia, Southeast Asia, and eventually Australia. Others moved northward into Europe, where they encountered Neanderthals, a closely related hominin species that had already established a presence on the continent. The encounter between these two human groups is a fascinating chapter in our history, one that is still being written as new discoveries come to light. For tens of thousands of years, humans lived as hunter-gatherers, relying on their skills and knowledge of the natural world to survive. They lived in small nomadic groups, moving from place to place in search of food and resources. Then, around 10,000 years ago, a revolution occurred that would transform human society forever: the advent of agriculture. In the Fertile Crescent, a region of the Middle East, humans began to cultivate plants and domesticate animals. This marked a profound shift in our relationship with the natural world, from one of dependence to one of control. Agriculture provided a more stable and predictable food supply, allowing human populations to grow and settlements to become more permanent. As villages grew into towns and towns into cities, new forms of social organization, governance, and technology emerged. Writing was invented, allowing humans to record their thoughts, ideas, and history. Trade networks developed, connecting distant communities and fostering the exchange of goods, ideas, and culture. This period, known as the Neolithic Revolution, witnessed the birth of civilization as we know it, laying the foundation for the complex societies and interconnected world we live in today. The invention of agriculture and the rise of cities marked a turning point in human history. City-states, ruled by powerful kings or emperors, arose in Mesopotamia, Egypt, India, and China. These early empires wielded unprecedented power and influence. They built grand cities, adorned with magnificent temples, palaces, and monuments. Empires expanded through conquest and trade, connecting distant lands and peoples. The Persian and Roman empires left an indelible mark on history. They fostered trade, spread new technologies, and left a legacy that continues to inspire us today. As empires rose and fell, a different kind of power began to shape human societies: the power of ideas. Religion and philosophy emerged as powerful forces, providing meaning, purpose, and a moral compass for individuals and communities. In the East, Hinduism, Buddhism, and Confucianism spread throughout India, China, and other parts of Asia. These religions and philosophies emphasized harmony with nature, respect for elders, and the pursuit of enlightenment. In the West, Judaism, Christianity, and Islam emerged from the Middle East, spreading rapidly throughout Europe, North Africa, and beyond. These monotheistic religions, with their emphasis on one God, a divine plan, and a code of moral conduct, had a profound impact on the development of Western civilization. The teachings of prophets and philosophers, from Buddha to Jesus to Muhammad, resonated with millions, shaping moral values, inspiring art and literature, and influencing the course of history. The clash and confluence of these belief systems created a rich tapestry of cultures, each grappling with fundamental questions about the nature of reality, the meaning of life, and the human condition. Following the decline of the Roman Empire, Europe entered the Middle Ages, a time of significant change. Spanning from the 5th to the 15th centuries, this era saw upheaval and transformation. The Roman Empire fragmented into smaller kingdoms reshaped by migrations and invasions. The Catholic Church emerged as a unifying force, promoting literacy and wielding power. The feudal system dominated, with lords granting land for military service. Despite challenges, the Middle Ages saw achievements in art, architecture, and literature. This period laid the groundwork for the Renaissance, ushering in the modern era. In the 14th century, a profound cultural awakening began in Italy, spreading throughout Europe and marking a turning point in history. This period, known as the Renaissance, meaning rebirth, witnessed a renewed interest in classical learning, art, and philosophy after the perceived stagnation of the Middle Ages. Scholars and artists drew inspiration from the ancient Greeks and Romans, rediscovering their literature, art, and scientific knowledge. The Renaissance was a time of great intellectual ferment, challenging established norms and embracing new ways of thinking. Artists like Leonardo da Vinci, Michelangelo, and Raphael created masterpieces that celebrated human form and emotion, while scientists like Nicholas Copernicus and Galileo Galilei made groundbreaking discoveries that challenged the geocentric view of the universe. The invention of the printing press by Johannes Gutenberg revolutionized the dissemination of knowledge, making books more widely available and fueling the spread of new ideas. The Renaissance marked a shift from a God-centered worldview to a more human-centered one, emphasizing human potential, reason, and the pursuit of knowledge. It laid the groundwork for the scientific revolution and the Enlightenment, which would further transform Western civilization. The Renaissance sparked a thirst for knowledge and exploration beyond Europe's borders. The Age of Exploration saw European powers embarking on daring voyages for new trade routes, wealth, and glory. Columbus's voyage in 1492 connected the eastern and western hemispheres, leading to colonization. The 18th century witnessed revolutions in Europe and the Americas, challenging hierarchies. The Industrial Revolution transformed production, with machines replacing human labor in factories. From the fiery chaos of the Big Bang to the intricate web of life on Earth, we have journeyed through billions of years of cosmic evolution. We've witnessed the birth of stars, the formation of galaxies, and the emergence of life on our own planet. The sheer scale of this journey can be overwhelming, humbling us with the realization of our small place in the vastness of space and time. Yet, this same journey also fills us with a sense of awe and wonder. We are a part of this universe, connected to every star and every galaxy by the same fundamental laws of nature. The atoms in our bodies were forged in the hearts of stars, the remnants of cosmic events that played out over eons. We are, quite literally, stardust. Our moment in time, here on this planet, is but a fleeting instant in the grand scheme of things. Yet, it is a precious moment, a time when we can marvel at the universe's beauty, unlock its secrets, and ponder our place within it. The universe is not a static, unchanging backdrop to our lives. It is a dynamic, evolving entity, and we are active participants in its ongoing story. Every breath we take, every thought we think, is a testament to the universe's remarkable capacity for self-organization and complexity. We are the universe becoming conscious of itself, capable of comprehending its own grandeur and reflecting on its own existence. As we stand at this pivotal moment in history, we face a multitude of challenges. Climate change, global inequality, political polarization, and the threat of nuclear war loom large. We possess the intelligence, creativity, and compassion to overcome these challenges and create a brighter future. The journey of humanity is far from over. The vastness of space beckons us with its mysteries. The spirit of exploration that drove our ancestors continues to burn within us. We long to understand the universe's origins and search for life beyond Earth. The quest to explore space reflects our deepest human instincts: curiosity, wonder, and the desire to transcend our limits. It is a testament to our belief in human ingenuity and hope for a brighter future. Imagine a future where we have established settlements on other planets. This future may seem like science fiction, but it is within the realm of possibility. The universe is full of wonders waiting to be discovered. The future is something we create through our choices and actions. Let us choose wisely, act boldly, and never stop exploring. For the universe is vast, and our potential is limitless.